Title for lesson 51 is negative exponents. We'll also be working with scientific notation. A little review. If we start with x to the fifth over x to the third, what was our rule there?
Subtract.
Yeah, we're dividing, so we subtract the exponents. 5 minus 3 gets us 2. Simple enough. We're going to be doing a lot of that stuff today. We get into our negative exponents rule, and believe it or not, you've seen it already. X to the negative n. We don't like negative exponents unless we're dealing with scientific notation. But if we do have that negative exponent, the good news is we can get rid of it by simply moving it either to the denominator, or if it's already in the denominator, moving it to the numerator and making it positive. Recall doing this? Your negative brother or sister, if they're being negative, move them to the basement, or if they're in the basement, move them upstairs. That whole concept. If we look at 10 to the negative second, that is equivalent to 1 over 10 to the second. That 2 is being negative, so we move it down below. And when you do these problems, if you can do 10 to the second, 2 to the, or 10 to the fifth, and so on, go ahead and do so. 1 over 100. On the flip side of this, let's say we had 1 over 10 to the negative third. Because eventually you'll be seeing these problems. Exponent is being negative, so we move it up top. Now if I move it up top, what's left down below in the denominator? Nothing, essentially, right? So 1. So we can actually just write it like that, where we know this is in the numerator. So you have that example as well. If we say we have 10 to the negative second and 10 to the negative fourth, you know, we said with our negative exponent rule that if it's negative, we want to get rid of it. But in this particular case, we can actually add these two, correct? Because we have common bases and we're multiplying. So negative 2 plus negative 4 will get me 10 to the negative sixth. And now I have just one base and one exponent. So it's now at this step, we want to move it down below. Ten to the sixth indicates that we have 6 zeros, therefore 1 over 1 million. Okay with that idea? Okay. Let's do another one. We have 10 to the negative second over 10 to the negative fourth. Dividing, so we do what now? Subtract. So a little scratch work off to the side. Negative 2 minus that negative 4. Do I like the subtraction sign? Nope. So we change it to addition. And change that negative 4 to a positive 4. So now I'm looking at negative 2 plus 4. Yes. And once again, I can do 10 to the second, knowing that that's 100. Very good. Two to the negative third. Going back to our negative exponent rule. Exponent is being negative, correct? So we need to move it. So we're looking at 1 over 2 to the third, and I know that 2 to the third is going to get us 8. Therefore, 1/8. Let's take a look at this one. They kind of flipped it on you, didn't they? Now instead of the negative being with the exponent, now it's with the base. Do we have to move anything here? No. Okay, they're playing games with you. This exponent is still positive. They just made it look like it could possibly be negative with a negative base. But again, the 3 is positive, so we don't have to move anything. Now I simply take -2 times itself 3 times. So just be cautious and leery of those negative signs. Is it with the exponent or is it with the base? Let's take a look at this one. We want to simplify 2x to the -1, y, x squared, y to the -2 times z. We are taking that next step in terms of difficulty, or level of difficulty. On a scale of 1 to 5, I would consider this to be maybe a 3 or a 3.5. The 2 is the only 2 that we have, so we're going to keep that the same. But as I'm looking at this, I notice I have a couple of x's. What's our operation between all of these? Multiplication, which means we simply do what with the exponents? We add them. So let's do it. You know, -1 plus 2 will get me what? Yeah, so you can write x to the first, or you can simply write x. Let's go to the next one. There's a y, and there's another y. Again, if it's not there, it's understood to be 1. So 1 plus a -2. Y to the negative first, right? And I know you hesitated to say negative first because you don't like the negative exponent, but that's okay. We will deal with that in the next step. Lastly, we just have 1z. It's positive, so it's right there. So now in our final step, we want to make sure it's all nice and clean. We have no negative exponents. The 2 is going to stay. The x is going to stay put. The z is okay. The only thing we need to move is that y. We move it down below, the -1 becomes +1, which we know we can leave as just y. That's going to be your textbook answer right there. Objective, you want to be able to write these things without any negative exponents. Unless you're working with scientific notation. (1.5 times 10 to the -3rd). Now, if it's a negative exponent, are we looking at a really big number or a really small number? So hopefully that's telling you, okay, I need a decimal when I do this thing. Now, if I start with 1.5, and I know now instead of going to the right to make a big number, I need to go to the left. 1, 2, 3. There is my new decimal with those right there. Agree? Last one. One, 2, 3, 4, and 5 zeros. Then we have that 7. I want you to write it in scientific notation. One, 2, 3, 4, 5. Do I need to go one more? Yes, I do. So that was number 6, correct? So I have 7. And you can write 0.0 if you want to, otherwise you can just write 7. times 10 to the 6th power. Correct? No? Oh. That'll be a common mistake that students will do. They will forget to add that negative. We are so used to working with really big numbers and positive exponents that we will forget to throw it in there. Kind of like with slope. We forget to throw that negative sign in there if we need to.